Hey everyone, welcome back. And this week we're going to really talk about data management, and by that I mean sort of having data into lists and kind of organizing those lists. And we'll do an example of creating a flower, and really we'll do just a way of managing lists of data. So if I take 6 points as an example. And last week, someone asked us about NURBS curves and some of the explanation of the curves. So I just thought I'd include a few slides to explain all we really need to know for these examples. So if we have 6 points in 3D space or 2D space, and we connect them with a curve, and we set the degree to 1, that means that basically you're just going to get straight lines. It's going to go from one point to the next. And each point is just sort of considering itself. So it's just one point. From a Rhino perspective, this may also be called a polyline, poly being just many, so several lines. If the degree is 2, what that means is the NURBS curve is considering the point, either side of its point, to consider how curved that geometry will be. So in the case of this curve, it's considering these 2 points for the left side and these 2 points, so it's really 3 points, to consider, so that curve perfectly forms sort of in that thing, and it kind of comes off the points, except for the start point and the end point. If it's a curve with a degree of 3, it gets smoother again, and it's now referencing, say for this point, these 2 points and itself, and these 2 points and itself. So it's kind of considering all 5 points just to determine the curvature at this point. And you can go higher, 4 and 5. It's not really relevant for this course. Some people do rendering at higher degrees and modeling at lower degrees, simply because your computer goes a lot faster if you've thousands or hundreds of thousands of points, and every single one of them has to reference 2 points either side of it, or 4 points. It's a lot of geometry to calculate. An interpolated curve is different in that this time the line just goes straight through the points and kind of makes its own kind of meandering way through the points. Evaluate curve is something we're going to come across this week, and that's a command to sort of see a point inside of a curve. So every curve has a domain. The default would be 0 and 1. So if I evaluate the curve at 0.5, that would be the midpoint. I can put 0.25 or 0.75, and that will be sort of a quarter way or 3/4 way in. But I can put a slider on that, and it will just find the point at whatever decimal division of that curve. If the domain, sometimes when you're like working on things, the domain changes, or you want to change the domain, reparameterize would get you back to a 0 to 1 domain, and we might look at that. So when you create points, if you create them in Rhino, the first point you create will be 0 in a list, will be 0, and 1, 2, 3, 4, 5 in this curve, 5 being the endpoint. So I think I mentioned it last week that when we make lists of points, because there's a 0, there's actually 6 points when you're kind of 0 to 5, off by 1. Sometimes as well, when you're dividing a curve, you're creating a number of segments, which means the number of points will be 1 more than the number of segments. And lists can be plus or minus 1, as long as you understand where those plus 1s are coming from. We'll have commands to shift lists. And in that case, that just means that we have the same points, all the points are in the same position, but we're going to make 0 at the end here, and then 1, 2, 3, 4, 5. And if we shift list by 2, we're just shifting the numbers. We could wrap the list so that the 0 and 1 comes back, or just create 2, 3, 4, 5, 6, 7. Then we have code patterns, and that's where we sort of set some points we want, some points we don't want from a list of points or a list of anything. So if we were to code true, false, it would go true, false, true, false, true, false, where the code pattern component selects 0, 2, and 4 and does not select 1, 3, and 5. Or we could cull index and sort of remove a specific item in the list and keep everything else. It's kind of the opposite of list item, where list item retrieves just one item. Cull index removes one item and keeps everything else. So we're going to do our flower example. We're probably not going to get onto weaving. It's just the same thing but different. But this would be kind of how you might use cull patterns that you kind of create in this case, a grid of points, 15 by 15 points. You move them on the z-axis up and on the z-axis down, and then you cull every second point and then tell a NURBS curve to go through every second point on different directions, and then pipe command, which gives it some thickness. And as long as you get all your cull patterns and numbers right, these pipes won't touch each other and they'll just smoothly weave through. And I'm going to upload the weaving pattern, which you'll recognize a lot of the commands, which will be uploaded to the Hackaday course page. And there'll be other examples of weaving, which kind of do get kind of complex with twill weaving. And all of these are created on surfaces. So if I was to make a sort of small little cylinder surface, the weaving pattern would be the same. It would offset one direction, offset the other direction, and weave a wire through it. So with that, I'm going to jump into Grasshopper, and we'll look at our first example. So I'm going to start in creating a flower by drawing a circle. And there's several types of components that all come under circle. There are different inputs to creating a circle. We want the CNR circle, which is a center point, a normal, and a radius. And as I mentioned last point, so for the center point, we need to create a point. So I could type point and then set the point manually, or I can just type 0, 0, 0, which is the XYZ coordinates, and it creates a point, which you can see is right on the origin point. Connect that in, and there's my circle. And I'm just going to give it a radius of 10, and that goes into the R. And I don't really need to worry about the normal, which is automatically set in the z-axis. And one of the most important things for understanding lists is being able to see the lists of information. And to do that, we can create a panel, which is this yellow squiggle thing here. And the shortcut for creating a panel is just //. And if I type anything after the double // such as, let's say 46, that would create a panel with that information, or I can type text or anything. And this 46 can be inputted into something just the way a slider could. It's just harder to adjust relative to the slider. So I can connect my circle to this panel, and it tells me what is contained in this list, which at this point is just a circle with the radius of 10. And this up here is the path, which is on path 0. If I was to connect the point, I would see the point, and I would see my XYZ coordinate of that. So that's all very simple. So I'm going to type series and range, bring both of them. They're slightly different, but kind of overlap. And this is how we kind of create a bunch of numbers all at once. So the series wants, you can kind of like hover your button over the inputs, wants a first number in a series, a step size, and the number of values, total values in the series. And you can see that they're already set, like the start is already 0, which is fine. I can just leave it at that. The step size is 1, and this is 10. So if I create offset for offset circle or offset curve, let me make sure I get this one with 2. I want to offset this circle. It's default setting there. if I was to connect the series into the distance, I get sort of several circles. And the reason is if I connect this into the panel, I can see what information that contains with its default settings. And it contains 10 numbers, 0 through 9. And I'm going to make a slider connected into the C. And the C is the total number of steps. So I can see my circles disappear from this side and the numbers disappear, which is telling me what is coming out of the series. So that's just the offsets, and that slider can control that. Range is similar, but instead of I think series is sort of bottom up and range is top down. In range, I'm going to set the maximum and the minimum and then divide it by a certain number, creating the increments, where for the series, I'm just setting the step size and the total number of steps, and whatever number that goes to, it just goes to. So I don't necessarily know what the maximum value of the biggest, the largest item is in the series, but in a range, I'm setting that. So the range asks for a domain, which we saw earlier what the domain was in terms of the curve. So we can construct a domain by typing construct domain. And we want this one with a 0 and 1. They sort of have different ones for area versus just sort of a distance one. So I connected, this one's a domain, so I'm going to give it a domain. Default is 0 on the top, which is the minimum. And let's just set the slider in there. And I'm going to copy the panel and just look at how it's different. So you can see the domain, I've set the maximum to 10, which means the last point is always going to be 10. And if I set the number of steps, it's just going to divide my largest number, giving me, so I'm setting the maximum on this one, and this one I'm just setting step sizes. So I connect that to that. It's kind of the same, but different. But in this one, you can see on the left over here that I've set the maximum, and I'm just setting the divisions between, where I switch to this one. It's sort of expanding from the center. So if I wanted those lines to be less proportional, less even, I can change the numbers by using an expression. The expression component is how you sort of insert math into Grasshopper, and you can get really complicated with, well, from my experience, all my high school math, but I'm just going to use x to the power of y. And currently it's empty, so that's giving us our red. And I'm going to put the range into y, and I'm going to set a number less than 0 or less than 1 to 2 decimal places. And as I said last week with number sliders, if I create any number between 0 and 1, it will just create a slider 0 to 1 as sort of real numbers. But if I do 2 decimal places here when I'm typing the number into the search, it'll be to 2 decimal places. And if I do 3, 4, 5, it'll just like that. So there's my number. And if I switch the panel to see what's in there, you can see I still have 8 numbers, but the numbers between them are changing. And if I make that my offset, you're going to see it there, and it's kind of small. So I'm going to use multiplier to make it a little bigger. I can just type the asterisk mark or type multiplication. That gives me multiplication, and it's just 100 there, and add into the distance. So now we have the circles, and you can kind of see there that they are not evenly spaced because we've used this to the power of expression. So I'm not going to keep all these panels because they get kind of messy, but they are feel free to use as many of them as you want to see all the information as you move it. So if I move the offset to this, that I can see the different curves here, which are all these offset curves. And you'll see these numbers here, which are double curly brackets and semicolons between them. And that is called path. And that's kind of what we're looking to manipulate. So all of these curves are on separate paths. And if we were to flatten the information by right-click flatten, they would go back to just being on one path and having all these curves. And if they were flattened and we wanted them all to be on the separate path, we would use the graph command. And you'll see how we kind of flatten and graphed information. It's kind of like grouping it, but a lot of time when you're trying to get different components to work in tandem with each other, you kind of need the lists to kind of coordinate with each other. And a lot of that involves flattening a graph, and sometimes it can be confusing, but it's something you get used to over time. So I'm going to delete these panels. And next thing I'm going to do is rotate these circles. So drag all of these curves, which is sort of 9 curves, into the rotation component. And by default, angles of components are in radians. I much prefer degrees. So I'm going to right-click and just change that to degrees. And rotation plane can say the same, but I need an angle. And I'm going to use a series. And grab this one from back here. And I want the number, which is kind of confusing here because it's going into n here, but this is the number of curves in the offset. It's the number of divisions in the range. I want that number to remain constant and come to the series. And that series to be our angle of rotation. And the step size of the series will be our angle of rotation. And this means the first one will be, let's say if it's 5, the first one will be 5, the second one will be 10, it'll go up in increments of 6 or 5 or whatever this slider is set to. So we can't currently see that because they all look the same, but we're going to divide it now and then we'll see how that component is working. So divide all those curves by default would be 10. We're going to create another slider. And this time I'm going to create a number slider slightly differently. This is a more advanced way to create a slider. If I do a less than symbol, and then another number, that gives me a slider between 0 and 20. Let's do 0 and 30. And make that one to end. It's currently 0. So that strange pattern is because of our rotation. Okay. Important I flatten that actually. So that's if I open up the panel. That was keeping them in sort of these groups, and I don't want them in those groups, so I can flatten it. And now all those curves are being rotated. The first one is at 4 degrees, the next one is at 8, and so on. And that you can see those rotating around using the series. So I'm really after these points, not really the curves, now that I have the points. And I have a bunch of sliders here that will move things in different ways. I'm going to label some of these sliders just so I know what they are for future reference. So this is kind of my rotation slider. I can type rotation on that one. And this is my number of divisions. And okay, so if we now try to move all of these points in the z-axis, we want to give them some height. And unit z. So unit z is the vector in the z direction of 1. And they're all evenly going up in the z-axis, which is not the one I want to know this series. And this one is connected to the total count that I want to keep. So if I copy that and I copy the slider, that will give me a new slider, but keep this C connected. And I'm going to connect that in there. Let's do a slider between 0 to 1. Perfect. Small. Okay. So what's happening now is it's raising the points, but it's raising each kind of group separately, and that sort of we correct using a flip matrix command. And that I'm just going to do a little side example to show you what I mean by flip matrix. So if I connect this panel to see what's in there, drag this down. Okay. So currently in these divided curves, which is these points labeled green, I have paths of 8 points on each of these circles. And if I want to change the order of them to be, let me just create a smaller number of divisions so it's more obvious. So there I have yeah. So each circle is being divided 3 times. So I have, I think it's 9 or 10 circles and 3 points on each circle. If I flip the matrix, then I have 8 points connected in groups of 3, which means that's a group, and that's a group, and that's a group. So now with my matrix, I'm going to move the flip matrix. So now you can see the points move differently. And they kind of move from tallest on the outside and smallest, or sorry, smallest on the outside and tallest on the inside. I want to reverse the list direction, which I can reverse list using a reverse list component, and move that into the move components. And now they're just the opposite direction. And it might be useful as well to put numbers on the points. So we can use this point list command just to clarify what I mean here. So you need to put a size of a font on a point list. So if I take these first points here, so that's where each circle has 0, 1, 2, 3, 4, 5. Then when I flip the points, I now have 0, 1, 2, 3, 4, 5, 6, 7, 8 in groups, where each group is kind of the same color. Then I reverse that list And now the 8 is at the other side and the 0 is at the other side. So that's point list as a kind of component. So now with these points kind of in the air, I want to use some vectors. And I want a vector 2 point. Let's select from there. And I want it from the origin point, which I could drag from my point here, but because I know it's 0, 0, 0, I'm just going to recreate it and keep my model slightly tidier. So from the origin point to my move point. And vectors are kind of like construction geometry, so they don't show visibly at first. You have to kind of create a vector display in order to see them. If you want to see them, you don't necessarily want to see them. And I can draw the V to the V. So that's the vector to preview. And a vector can be moved from any to different points. It's a magnitude in a certain direction. So if I was to create the vectors on the origin point, which is where they were created, I can see that that is from the origin point to every single one of these red points. But if I was to create the same vector, which it's already created, the magnitude in that direction, and move the vectors so that they're sitting on the points themselves, then my vectors are all sort of moved outward. So this vector here of this green line is the vector from the origin point to this point and then moved outward to the point itself. So it's just kind of moving them all out, creating this kind of spiral effect. And a vector is really just a point. So if I add a vector and a point, I will get a point. That makes sense. So if I take the point here, sort of my points in my spiral, and then add the vector to it, then I get the endpoint, which is a strange way to get endpoints, but that's how you get endpoints using vectors. So I can now make that a line. Oops. By connecting my, okay. So now there's my line, and that's kind of going to be my stem for each one of my leaves. And I can turn off a lot of this geometry to kind of get it out of the way by selecting the components and typing Control Q. And I have implements. So I want the endpoints, which I could just reference back to the previous points, but it's just neater just to create a new component, which gives me a start and an end. And I want to use evaluate curve, which is what I mentioned in the slides. So evaluate all of those curves. And the domain of all these lines is 0 to 1, even though those lines are of different length. The domain is 0 to 1, so 0.5 will be the midpoint of all of those lines, despite they have all different lengths. So I want a slider between 0 and 1 with 2 decimal places, and I put that into the t, which is the parameter. And now, as I move this, you'll see it's basically going at different points on every single one of those lines. And if I was to open up panel, I can sort of see how these things are being grouped. And you can see the different paths, and it's sort of good to check what's going on with the lists and the data. So next thing I want to do is to make this into a leaf. I want to sort of take a point and move it to each side of this sort of midpoint or evaluated point. So there's several ways to do that. I'm going to create a horizontal frame on every single one of those points. So I need to, sorry, connect the line to the curve and give it its own, use the same T. So that's kind of created this plane on every single one of those points. And I want to deconstruct the frame. And the reason I'm kind of creating that is the XYZ is set to each one of those curves, to the normal of the curve. So they're all perfectly rotated to align to the curves. Deconstruct point. And I'm just looking for the y-axis, I think, of each one. And that's all of the x and y are now sort of local to each one of those curves. I'm going to control Q just because it's kind of busy. And so I want to move the evaluated points a unit y amount. Actually, sorry, I don't do that. Yeah. So I'm just going to multiply the y direction. I think that should give me. Yeah. So all those points are going slightly off in one direction, and I want to reverse the vector to go an equal distance the other direction. Kind of messy what's going on there. I might make this slider much smaller. There we go. Okay. So, and now I'm going to draw a NURBS curve and bring our endpoints, just grab it and bring it to the end here. So now I want to go from start point to one of the midpoints, hold down shift to add together to end point. And you can see here that it's connecting lots of points together, and that's because I need to either flatten or graft or change the list in some way. So I can open the list and see it's sort of in these groups of 8. So I can right click and do flatten here or graft, or I can create components for them. Actually, sorry, I should graft it, I think. Yeah. So that's sort of putting them on their own branch, each of them. And now I'm going to do start the other direction and the other endpoint. And both of these are orange because they're a third-degree curve and they only have 3 points. And it's not enough points to, I mean, it still kind of creates the curve, but really we can just reduce that down to 2. This is the degree. Sorry. Oh, this needs to be graphed as well. Yeah. And now we're beginning to see the edge curves of our leaf shape. So we need to join the curves. Currently, they're two separate curves, and put a join curves component, and then create a surface using our join curves. So if I move this slider, that's the sort of thickness of the leaf. So I might do slightly bigger. So there goes as leaf thickness, or width rather. This is our evaluate curve. It sort of changes whether it's sort of even in the middle or kind of thicker at the bottom or top of the leaf. I'm just going to call it the dog curve. And so this is moving the height from earlier. I'm going to label that one as height. And now, if I go back to the beginning and I start messing with the, I'll get way more geometry, or be able to rotate more. Going back to a flat rotation, that you can see it's creating all of those things directly on top of each other. And that's kind of, I guess, an example of drawing leaves and flowers. So I hope everything's clear, and any questions after the week. And I'll talk to you next week when we do grids.